Welcome back. Today, we will be talking about database exploitation. So basically, guys, we have multiple types of databases from MySQL, MariaDB, and also we have Oracle databases. In this video, we're going to talk about MySQL and Maria database. So basically, Maria database is an extension of MySQL, so it's not considered a separate kind of databases, right? But basically, the exploitation and testing of both databases differ in various levels. So in this lesson, we're going to talk about the exploitation of these two databases with simple examples, and we're going to demonstrate some advanced knowledge later down the road. So for this lesson, I'm going to use Metasploitable. So I'm going to connect to the database. My database exists at the address 192.168.94.134. I connect. Okay, now this scenario that we are laying down in this video, guys, assuming that we have the username and password of the database. So this level we are, the level we are at right now is an advanced level during your penetration testing. So assuming that we did the enumeration, you did the analysis, you did the reconnaissance, and you have gained some kind of limited shell access, or you have gained in some way you have found the database credentials. So now we're going to explain how we can convert the limited access we have on the database into a root shell. So basically here, whenever we are on a MySQL database, guys, or MariaDB, we want to know what are the variables of this database. So we can do that using show variables. Why? Because variables here show and display great details about the software of the database and the current settings. So for example, if I can go up, I can see various variables and their corresponding values. Now, what's important for me here is if we go down, if we scroll down, we want to see the directory file. So here the directory file where the database lies actually. So this is the directory file of the MySQL database in the host we are testing. Now we can also view other variables. If we scroll down, okay, so we can see here the version, right? So 5.051a. That's the version of the database. Now you're gonna say, oh, I have root access to the database. Why would I care about the version of the database anyway? Now, basically, guys, the version of the database may reveal exploits or other techniques or vulnerabilities that you can harness in order to convert your access to database into a root shell on your side, right? So you don't need to, technically you can do privilege escalation of the database. So basically, the next step, we can go to here and clear the screen using search exploit, and we type let's type MySQL first. Now here, as you can see great details here and so much info. Now what I need here, guys, that's the version. The version is 5021A. So here is we have one, this is the remote denial of service. We don't want this. So basically, as you can see, 5.0 onward, all the way here, we can see the current vulnerabilities we can use against this database, or we can exploit, right? Okay, great. Now, suppose that you haven't found the version or a vulnerable version of the database you are enumerating. So what you're gonna do here? Basically, guys, you can use vulnerabilities, right? Like you can use some of these exploits and apply the concept of it on this database, right? I'm going to explain that later in the video. Now, we're going to continue on the enumeration. Now, second, we go back, and here most importantly, guys, we want to know if there is a plugin directory in the database. Why? If I scroll up, I cannot see variable for plugin directory. So you can, without scrolling, you can do select plugin directory. So it's saying there is no variable called plugin directory, which means that the current database doesn't use plugins. And the use of plugins in databases have introduced many vulnerabilities, among them the use of system function to execute commands. So basically, execute commands can be done through plugin directory, and it's a functionality used by system administrators. But since we don't have it here, we cannot look for an exploit to use this plugin directory. But in this video, guys, I'm going to explain to you how to use that, right, in order to gain access to any database you want. Okay. Show databases. So we have, Metasploit, MySQL, plugin, and the rest. Now, if you have the root credentials of the database, I don't think you are interested in enumerating and displaying the values of the tables, right? So we got the root password. What do you want else? What we want else is we want to convert the access we have from MySQL into root shell. Okay, so we're assuming now that among these exploits, we haven't found the exploit we are looking for, right? All right, now, if we go down and search again for search exploit UDF. Okay, so UDF, as you can see, I'm going to tell you what is UDF. So we have one for common execution, user-defined, and we have other two vulnerabilities for this. And we have one for PostgreSQL. There is doesn't appear to be an existence for MariaDB for the user-defined function. Now, what does user-defined function do, guys? User-defined function allows system administrators to transfer shared object files into the database in order to execute commands. So if we can create a user-defined function and transfer a shellcode of our own after we compile it into a shared object, we may gain root access, or we may execute system commands on the database to have root access, since we have root level privilege here on the database. So we can do whatever we want. To demonstrate the concept of user-defined function and how we can use this to execute any data, to exploit any database, guys, at least you try it. I'm going to demonstrate this exploit. I'm going to open the file and explain it. All right. So let me check. Okay. So as you can see here, guys, if we go to Firefox, or let me tell you something, we don't need Firefox. Okay. So as you can see, you can find this exploit on exploit database website. It's titled MySQL user defined, and its objective is to create a system function to do local privilege escalation, right? Okay. Now let's explain this exploit in order to understand the concept. So basically here, we will start with this. So as you can see, the first thing we notice, guys, is a shellcode. We have two shellcodes. Defined online, as you can see, 40 and 41. Now these shellcodes are kind of payload, right? It could be a payload created with MSF Venom, or it could be a hexadecimal representation of a payload. It's hexadecimal representation, actually. This is hex variable, hex value, right? So this is a hexadecimal representation of some payload, right? And this payload must be in the shared object format. I'm going to tell you what this is later. Okay, now we go down, here define the username and password, and we go down, okay, in this line. So in this line, guys, as you can see, we have kind of SQL query here, starts from here, that query the plugin directory variable, which we couldn't find on Metasploitable database. But this plugin directory holds all the plugins and holds all the shared objects that through which we can execute our shellcode. That's why it's important to enumerate the variables on your database and look for the plugin directory. Once you find it, then you can go further with your exploitation using the user-defined function method. Let's go back. All right. Now, if you go down, okay, here, OS system. So in line 92, as you can see, the code here use dump file, the function dump file or the query dump file. So the code here dumps the shellcode binary content into a file. So the shellcode binary content is this one, right? You're going to create on your own, right? It's going to dump the shellcode content into what? Tell me. Into an output file. So the output file is this one, which exists in the plugin directory. So basically, we are transferring the shellcode we have created into the plugin directory. Okay, we go down, scroll down. Okay, on this line, OS system as well. So here it creates a function named this one. So this query creates a function called system execution, leveraging the uploaded binary file, right? So basically, here we are executing a system function, and the script checks if the function was successfully created on line 104. So here it checks if the function we created here has successfully been created, right? Okay. Next, after we create the function, we need to execute it, right? So we go down to the line where the function is executed. Okay, line 113, this one. All right, so here is the line where the function is executed. And as you can see, they define root as the owner, and that's why this exploit or this kind of exploits require you to have the root password of the database, which means that you are way further on your penetration testing let me say journey, right, or plan. Okay, so essentially, guys, this is what the exploit does. So first thing, we need the plugin directory to be set, right? Second, let me go back. We need to, technically, guys, this exploit is ready to use. You can use it on your if you are inside the system or if you are inside the machine, you can use it actually. So here, if you're going to use this payload on its own, let's go to desktop and exit that. Okay, so here we're going to say sudo python 2 this exploit will not work on the Metasploitable database. Why? Because there isn't plugin directory at all. I know we can create it, but if you don't see it, I don't recommend you to create a plugin directory for a database which doesn't have said directory. Why? Because in production system, you would mess things up actually. So if you're doing a penetration testing for your clients and you haven't found the plugin directory, don't try to smarten your ass up and create a plugin directory to prove that you can exploit the database, right? Don't try it, just leave it as its own. Now here in Metasploitable, guys, without a plugin directory, this exploit will not work because there is no plugin directory, as I told you guys. But for demonstration purposes, you know the idea now. Okay, let's see what will happen. Okay, so it defined username and password. So username root. I'm not sure of this. Okay. Equal. Of. So it's asking for the username, which is root, and the password is blank. But for some reason, it is giving out syntax error. Okay. Okay. You root. You see, I don't know why. Okay. So the password for metasploitable root is blank. So it's saying cannot connect. Why? Because I'm executing the exploit, guys, from my machine. This exploit needs to be executed from the box you are testing, assuming you have limited shell access, right? Okay, let's go back and explain to you how to create. Let's go back to the exploit actually. Sudo nano 46. Okay, so let's say, guys, that you have found a plugin directory, right? And you want to apply user-defined function vulnerability or exploit, sorry, on this machine, right? But how do you get the shellcode? Now, the shellcode here is the hexadecimal representation of a shared object, all right? Now, how do we go about creating this shared object? So basically, guys, if we go to Firefox and we go to, and then we type GitHub, what was the name of the project? GitHub. Lib MySQL UDF. UDF library. So we need to import the library first. So we have here multiple files, among which is the shared object. That's the file you need to import. Okay. Okay. Let's now clone this into our system and see how this works. Let's go back or keep this here and we go back to this clear. Okay. Git clone. Git clone. Sorry. Okay. Let's go to the directory. Okay, so now we have the C file and we have the shared object file. All right. Okay, let's first understand how we can use these files. So we have shared object file and we have C file. All right. Basically, guys, in order to use this effectively and create an exploit out of it, we need to understand and know what is the database we are exploiting. So in case it is MySQL, or in case it's MySQL, you can leave this as it is, right? But in case it's Maria database, you need to do some modifications. Let's first explain the C file and how this works. Nano lib. Okay, let's go down. I think this line, we need to find the system execution function. Okay, here it is. Oh no, not this one. Okay, this one. So here, as you can see, according to this code, guys, the function exported by the shared library after compilation is named this one, system execution, right? So technically, this C++ file, actually, guys, it's kind of, shows a fairly standard UDF library that allows for execution of system commands through C++ system function. So from this, in this section, we understand that this C file allows us to execute system commands, right, through the user-defined function. And that's how we can use this and import it into the plugin directory of any database to execute system commands. Okay. Let's go down. Okay, now, but there is something missing here you need to add actually. Here, after this finishes, we need to declare or put return in order to execute the system command. So system, and we put the arguments, args 0, and we close this. Save the file. Okay, we're ready. Now, the next thing, guys, we need to compile this. And in order to compile this, guys, we need to use the install.sh file and the make file. All right. But before compiling this, we need to take a look at the make file first. Why? Because as I told you guys, this is a general exploit. It works on MySQL, but it may not work on other versions. So we need to make the difference between them. Make file. All right. So I understand from here is that user include MySQL. Okay, from this line, we can conclude that this shared object is for MySQL. Okay. Now, how can we make it for, let's say, Maria database, which is used widely actually? What we can do, we can copy that and paste it here and do our modification. So instead of that, we can do here user. Okay, this one we shouldn't have removed it, MySQL. Okay. Shared library. I think this one also work on Maria database. Or what do you think? Or I think we need to modify a bit. So here we modify MySQL and put MariaDB server. Okay, let me remove the rest here. I don't need that. Okay, now from here onward, we can type user include MariaDB. Another one, user include MariaDB server private. Okay, and now put shared with the name of the file, UTF. All right, and you are done for the install. Actually, you can use this make file. Now, if you want to use it for compiling a shared object for MySQL, you're going to remove this line and leave this. If this is for Maria database, remove this line and keep this one. right? Okay, let's exit. Now the next thing we can type make. Yeah, I know, because I'm not executing on the testing machine. It's going to give error. Now all of this needs to be done, or all of this needs to be done after you install the dependencies actually. The dependencies is we need to do sudo apt install default and install library MySQL, and okay, let's install it first. All right, let's clear make. There are some warnings. Sudo nano. Did you give permission to this file? Also, we need to install the crypt edge. All right. Okay, now, since the target is MySQL, now this works for MySQL. And if your target is MySQL, you don't need to type make, right? You just use it as it is. But if your target is Maria database, okay, you need to modify the C file as I told you how, and then make the file. And when you make the file, it's going to give you a new shared object library, which you're going to use to import in the plugin directory of the database. Now here, but for some reason I cannot execute it. Here the crypt edge, the header. How do we go about this header? Let's Google it. No. So the header file, we don't have it. So we need to install the headers, which we have already installed. Or I have an idea. I think we need to type sudo apt update before we attempt the installation. Okay, let's try installing the headers again. Let's go back. It's saying, okay, let's try this without the default term. Make what about this? I think we forgot something, guys. No, technically, we didn't initiate the install actually. This one. I keep getting errors saying need lib MySQL client development software install, and I have it. Okay, I think there is a different version for this. Sudo come on. So what do we do if you don't have it and it can't be installed for some reason? Let's Google this. apt-get install y python pip run apt-get install -y. All right. Okay. Okay. So if we try these, so it's saying I have broken packages. So I'm not going to waste your time, guys. I think it needs some fix on my side for the packages, but let's not deviate the video and we go back to the topic. So after you modify the C file according to the database you want to target, and you make the file, you're going to have a result of shared object file. Now the next thing we need to do, guys, is to convert this shared object that we're going to import into the library. We're going to import to the plugin directory of the database into a hex file. So we do that, use xxd, and the file is this one. Let's copy it. I'm tired of copying and pasting. Okay, and then okay, we continue the xxd command, and we output this to the same one, but with hex. So, hex. All right. Is there anything else we need to do here? Okay, so here we need to output this on different lines. Okay. Now, let's list the content and cat this. All of this. So basically, we need to import all of this. This is too much. Let's clear. Okay. So here you copy the content of this, all of it. And you end this. And the next thing, guys, we need to do is to start exploitation. So we go back and we connect to the database. Okay. The next thing we need to do, guys, is to set the variable. So first, let me open a new terminal and go back to the code. Nano 46. So we go back here, we use the same method of this exploit. So we need the shellcode actually here. This shellcode, we will import it into the database and define it as a variable. So here we go back to the database and we set a variable called shell equal 0x and we put the exploit and enter. Oh, I forgot the okay, so note here we added 0x to the beginning of the shellcode, and as you can see, we didn't type double quotes or single quotes. This is necessary actually. Why? Because we are using or we are testing MariaDB database. It's necessary for a MariaDB database to read the text as binary. Okay, let me try my luck, but this is not MariaDB database. It's not going to work. I'm showing you only the required steps. Okay, now the next thing, guys, we need to do here to import the shellcode into the plugin directory. So we do that by using select binary and the variable is shell into dump file. And here is the plugin directory. How do you get the plugin directory? You use select plugin directory. Let's say there is no plugin directory because there is none actually. So we go back here to the import command. Binary shell into dump file. And here we put the path of the plugin directory. In case it is whatever, we put here the path. So typically it is var lib MySQL plugin, right? And here you put the name of the shared object. Let's say it is UDF right? Now, after we execute this, command, guys, the shell content of the shell variable will be imported into the shared object in the plugin directory. And from this point onward, we're going to be able to execute system commands. Now, let's suppose that we have imported the shellcode into the shared object of the plugin directory. What comes next, guys, is the execution or the obtaining of root shell from this MySQL database, right? Okay, so on a separate command here, we start a listener. Let's say it's Python for simplicity. Python 3. Okay, so now I have a listener, and from here, I'm going to use what we have built on in this explanation, okay, to obtain root shell, right? Now, if this command has succeeded, right, The next thing is to use the system execution function to execute commands. How? Select sys execution for open parentheses, and here you put the command you want or the CMD you want to execute to test out. So basically, in my case, I have a listener here, right? So I'm going to try wget and put the address of the machine, our machine, typically, and we enter. I know because there is no plugin directory, as I told you. So here we'll connect back to the server we have, right? So this one is kind of wget. It's going to connect to our server and retrieve whatever file in the home page or in the index. Now, let's say that we want to execute a system or a payload that will connect back to our machine and give us the root shell. So how do we do that? We use first Metasploit. So we go back, generate a payload, and from here we type sudo msfvenom p linux reverse TCP lhost lport, and then we put the file format. Okay, then we have the exploit, guys, right? We take this file, we put it in the web server directory of our attacking machine. In this case, it is in var HTML, okay? And then all we have to do is to go back here, use wget, but instead of this, we put the file. And once we get the shell, or we download the shell here, we're going to be able to execute it. So here, instead of this command, we're going to type select system execution, and instead of wget, we're going to say here chmod, give it permissions, and like this. This one will execute the shell that we have generated with Metasploit. And assuming that we have a listener set up with Metapreter, right, then we will be able to execute this. How to execute it? Just the same command here, we put this. And after we execute this, we're going to get root shell on Metapreter. I'm sorry, guys, I couldn't replicate the production actually, the testing environment. I couldn't replicate the testing environment exactly how I wanted, but I tried to explain the idea to you guys as much as I could, because it's very important to understand the concept of user-defined function in exploiting databases. All right. Now, if you have any questions about this concept, you can send me a message on LinkedIn, or you can put your comment in the comment box, and I will be answering you as soon as possible. Thank you so much, and hope you enjoyed this.